is that, make sure something's there.
So it does show, that's the right answer.
There's one S over here.
But I swear there was something about that. There's two different ways to write it.
Yeah.
I'm trying to pull up an answer. So,
Easily A out over there.
cause that's why I put a question mark on it.
That's how you do it.
Well, let them know. Isn't the charge +6 in the table?
Oh, this
That's
is,
why
this is what makes it hard. You see that,
I thought it was +6. I could be wrong.
those are both,
Let me see here.
those are both great.
Excuse me, I have a quick question.
Yes, sir.
You sort of like that, right?
If it's a lowercase g, is it a subscript or a
A
Yeah,
lowercase.
so each, there's three of those, right?
It's not a capital, it's two M's and then there's like a medium size.
G's, right?
Oh, MG, that's magnesium.
Yeah.
That's
We can't
one symbol
add
for the other.
because
Oh, okay, so
if we put it two in front of this.
for that, correct?
Which is
No,
six, so there's
because
6 O's.
Basically, a subscript,
Oh,
and for that matter, the coefficient has to be numbers. Ma'am? Make sure you
right here, so.
have one of those.
Yeah. These O's, this is right here, and 4 O's this side. So.
Okay, I think my live stream is on.
Just.
Oh, all right, folks, let's get this party started. Let me, share my screen. Okay, so this chapter is dealing with a very important skill that you guys need to master before you can do anything else in this course, right? And it has to do with balancing equations. Now, what do we mean by that? All right, now let me remind you of a particular law that you learned earlier, which is the law of the conservation of mass, right? And basically what that law says is that in any chemical reaction, the total mass is conserved, or another way of putting it, the total mass of the products would be equal to the total mass of the reactants that you started off with, right? And then Dalton, he came up with his atomic theory, and he explained the reason why that is so. And the reason why, according to his theory, that takes place is that in any chemical reaction, the atoms themselves are not created nor destroyed, right? In other words, whatever the number of atoms that you have represented on the left side of the equation must be equal to the number of atoms of the same element on the right side of the equation, right? So balancing an equation is basically reflecting that fact for chemical reaction. Now, what I'm going to do before we start this assignment here is give a very simple example of how to balance an equation and explain some concepts which are important when it comes to that. Now, if you're given this equation, if you're given H2O to form H2 and O2, all right? Now, in this equation here, this equation is not balanced, and I'm going to explain why shortly. Let's start by looking at the hydrogens on both sides, right? Now, according to what we have here, we have 2 hydrogens on the left side of the equation, and we have 2 hydrogens here on the right, right? So as far as the hydrogens are concerned, they are balanced. However, when it comes to the oxygens, there's only 1 oxygen atom represented here, and you have 2 oxygen atoms represented here. So obviously, they're not equal. So the equation is not balanced simply because the oxygens are not balanced, right? So the question is, how do we go about balancing an equation of this type, right? Well, let me just start off by telling you what you cannot do. You cannot make changes to the subscripts. Cannot do that. Because basically what you've been doing is changing the formula for the compound. You're creating a new compound on paper, right? Can't do that. So that's one thing you cannot do. So let me erase that. Another thing that you cannot do is simply add an extra atom of oxygen on this side. Right? Cannot do that. Okay? What you should do in order to achieve the balance is make changes to what we call the coefficients. And the coefficients are basically the numbers that appear at the front of the formulas in any equation, right? So in this particular case, because I have 2 oxygens here, what I would do is just erase this here. what I would do is I would place a 2 right here. I'll place a coefficient of 2 here to double the number of oxygens so as to balance the oxygens. However, because I placed a 2 here, that also doubles the number of hydrogens, right? So I have to balance that as well. How do I do that? I place a 2 there. And therefore we achieve the balance of everything. The hydrogens are balanced and the oxygens are balanced. All right. So this is basically what you do when it comes to balancing equation. You make changes to the coefficients of the different substances, and sometimes you have to go back and forth. Sometimes you have to go back and forth, and you probably place a number in one place before, and then you have to make changes and erase that number, replace it with another number. So it's a bit of a trial and error kind of exercise. All right. Okay. So let me see if I can come up with another example. Let's say you're given this unbalanced equation. All right, let's say you're given that, right? And again, you're asked to balance this equation. So what I would do is, I would examine each element starting with hydrogen, right? So I have one hydrogen atom here, I have 2 here, right? So what I would do is put a 2 here. All right. And then now I would look at the nitrogens. I have 2 nitrogens here because this 2 affects everything within the formula, right? So I'll put a 2 in front of the NO2 here to balance the nitrogen, all right? So now we get to the oxygens. The total number of oxygens that we have on this side is 2 plus 3 is 6. On this side, we have 2 times 2, 4, plus 1, 5, plus 2, 7. So the question is, how do we balance the oxygens? And this might look a bit unusual, but what I would do, and there are several ways of approaching this, but what I would do is, I would place a half right here, right? And the reason why I would do that is because half of 2 is what? 1. 1 plus 1 is 2. 2 plus 4 is 6. And that balances with the 6 oxygens on the left. However, this will not be the final answer because conventionally, when it comes to writing down or balancing equations, we use coefficients that are integers, right? So I have to multiply this by a number to convert it to an integer, which obviously would be 2, right? But that 2 would multiply everything within the formula, right? So I would multiply this by 2, everything by 2, and the final answer would be 4HNO3 to give 4NO2 plus 2H2O plus O2. And that will be the final answer. All right. Okay, any questions about this? Any questions? Questions? All right, so with that said, let me clear this and scroll down and let's see if we can answer the questions. Now, the first exercise, it says draw a circle around each subscript. Now, the subscript would be the smaller number, which is immediately to the left of a particular formula for an element, all right? So that's the subscript, and that should not be confused with the coefficient, which is the larger number, which is placed in front of the formula for a compound or a substance, right? So in the case of H2O, okay, so the question says draw a circle around each subscript and a square around each coefficient, right? So in the case of H2O, I will put a circle around the 2 here. In the case of the 5CO2, I'll put a square around the 5 and a circle around the 2. In the case of the 2 magnesium here, I'll put a square around the 2. And then in the case of the 3 hydrogen peroxide, I'll put a square here and 2 circles, 1 each around each 2. That's it. All right. Okay. Any questions about it? Any questions? All right. So the next question is to balance the following equation, right? So how would you balance this one based on the example that I showed you earlier?
2141.
You said what?
2141.
You sure about that? 2, 1. Oh yeah, you're right actually. 2, 1. And by the way, you don't need to put a 1 here. It's all in chemistry, it's understood that it's 1, right? So it's a 2, 1, 4, 1. Yeah, I think that's correct. Yeah. Okay, very good. Let me see here. What about this one? Number two.
Two,
Two what?
two.
Two, and one here, okay? What about number three?
Two, one, two, three.
Two, one, two, three. Let's see here. Two, three. Okay, yep, I would agree with that. And then the last one here, number four.
8, 16, 1.
8, 16, 1. Very good. Oh, some more here. Let's see that one. Okay, wait, let's see. Okay, what about number 5?
3, 2, 1, 1.
3, 2, 1, 1. Let me see. Check. Two phosphorus. Okay, that's correct. What about number 6?
2, 1, 3.
2, 1, 3 would be correct. All right. There it is. Let's go down. Okay, it says given the two chemical equations, circle the one that is balanced. So in each case, you're given two equations. One is balanced and one is not. So what's the answer for number 1? I mean number 7. Sorry. A would be correct. What about number 8? Number 8. What say you?
A.
A would be correct. Number 9.
B.
Be correct. And number 10.
A.
Yep. Okay. Okay, so some sentences are given with some blank spaces, and basically this is discussing what we talked about earlier. So let's see if you can fill in the spaces. So the first sentence is that atoms are not dash or dash during a chemical reaction. So what would you put here and here?
Destroyed or created.
Right, so created or destroyed during a chemical reaction. Chemists know that there must be the blank number of atoms on each blank of the blank.
Say.
I'm sorry?
Say.
Same or equal number of atoms on each.
Side.
On each one.
Oh, on each, side of the.
On each side of the
Equation.
equation. Okay, to balance the chemical equation, you must add
Coefficients.
coefficients in front of the chemical formulas in the equation. You cannot blank or blank subscripts.
Add or subtract.
Add or subtract subscripts. Subtract. Okay, very good. All right. So let me do this. Go down. Okay, so now we get into the heart of this exercise, balancing chemical equations. So let me hear what you have to say for a couple of these, starting with number 1. How would you balance number 1? Well,
Right?
here we are.
Straight by the. Like,
Okay. What else?
and then,
1331.
Yeah, 1331. Exactly. Okay, any questions about that one? Any questions? Okay, what about number 2?
1112.
Let's see. Yeah, that will be correct. What about number 3?
132.
Yep. What about number 4?
112.
Okay, yeah. What about number 5?
2112.
2112. Yep. What about number 6?
1212.
1, 2, 1, 2. What about number 7?
2111.
Okay. Clear this here. Let's go down. What about number 8? One. Straight. Yep. No, this is 3. Sorry, yeah. Okay. What about number 9?
1111.
Here, 1 right, Joe, so I don't need that in. Okay, and then number 10.
132.
1, 3, 2. Okay. So I'm gonna leave the rest of that for you to do. Right, if you have any problems, please let me know. As you can see, I've given you quite a lot. By the time you're through, you should be experts in balancing equations. And that's very important, as you're gonna see later on. Next, well, not the next chapter, the chapter after that, we'll be dealing with stoichiometry. Stoichiometry is basically that part of chemistry which deals with quantitative relationships between different substances. And what you're gonna see when you get to that stage is that in order for you to solve those problems, you need to start off with a balanced equation, right? In some cases, you may be given a balanced equation. In other cases, you may be given an unbalanced equation. And based on the unbalanced equation, you have to balance it first before you can do the problem. So that's the reason why I'm giving you all of these problems so that you can become very proficient at balancing equations. And that's important for other problem solving. Now, section C is where they gave you a description of reaction in words, and you have to figure out what the balance equation is. All right. So whenever you're given this type of question, the first thing I would do is try to, based on the question, figure out what the reactants are and what the products are. And then the next thing you have to figure out is what the formulas are. All right. And then after you figure out the formulas, you end up with your unbalanced equation, and then you have to balance it, and then that's how you solve it. So I'm just going to show you how to do for a couple of these. For the first one, it says potassium reacts with water yielding potassium hydroxide and hydrogen. So the first thing I would ask myself is what would be the reactants? And looking at this statement here, I can see that one of the reactants would be potassium, and the other reactant would be water, H2O, right? Then you have to figure out what the products are. One of the products is potassium hydroxide. Now, if you remember, in the previous chapter, we talk about nomenclature, right? This is where that becomes important because they gave you the name of the compound in words, right? So you're going to need that table. Remember the table I talked about, right? Which gives you the list of common ions. You look up the formula for potassium, which would be K plus. You look up the formula for the hydroxide, which is -1. So that's the formula for potassium hydroxide. So you're going to put that here. All right? And then now, when it comes to the hydrogen, you have to remember that hydrogen is one of those elements that exists as a diatomic molecule. I don't know if you remember that. Right? Hydrogen, let me just give you the list of diatomic molecules. Hydrogen, oxygen, nitrogen, fluorine, bromine, iodine, chlorine. I think that's it. Yeah, that's it, right? You need to memorize these because you need to remember that they exist in nature as diatomic molecules, right? Also, you need to remember while I'm at it, that sulfur exists as a tetraatomic molecule. And no, I'm sorry, sulfur exists as S6. Phosphorus exists as P4. All right. So you need to remember these as well. All right. So in this case here, we're dealing with hydrogen. So therefore, we put down the formula of hydrogen as H2. And then we balance it. So we put a, okay, so we have two hydrogens here. Okay, so we'll put a 2 here, 2 here. No, wait a minute. We have 2 potassiums on either side, 4 hydrogens, and 2. Okay, so that's the equation. All right. So that's how you answer a question like this. Okay, any questions about this one? Any questions? Questions? Okay, for the next one, it says chlorine reacts with potassium bromide, yielding potassium chloride and bromine. So my question to you is, based on the information provided, what would be the reactants and what would the formula for the reactants? Let me put it that way. What would be the formula for the reactants?
CL2 plus
Cl2 plus
KBr.
KBr. Okay, very good. And then what would be the formula for the products?
KCl
KCl plus
Br2.
Br2. And that would be the unbalanced equation. So now we have to balance it. So how would you go about balancing it?
1, 2, 2, 1.
Yeah. So 2 goes here, and 2 goes here. And that would be the balanced equation. All right. Any questions about this? Any questions? Any questions? Okay. The next one. Okay, let me hear what you have to say. What would be the reactants? What would be the formula for the reactants? Zinc, Zn plus
HCl.
HCl. Yep. And then what would be the products? Let's start off with the zinc chloride. What would be the formula for the zinc chloride? So again, that chart is important, right? What's the formula for the zinc ion? Zn what? What's the chart?
CNCl. CNCl.
Well, you need to know what the charge is first on the zinc.
CnCl2
Okay, that's the final answer, but I want the charge. What's the formula for the zinc ion?
plus 2.
Plus 2, or 2 plus, right? And the formula for the chloride ion is
1.
Cl minus 1, right? So to get this charge balance, you need 2 here. So this comes together to form zinc, ZnCl2. So that would be what you write here. So you see, it's very important that you know what the charges are. Well, you don't have to know it because you have the tables. You have to refer to the tables so that you can determine what the formula for the ionic compound is, right? So you cannot just put ZnCl, right? It would be ZnCl2. Okay, and then hydrogen, we all know what that is, H2, right? So now we need to balance it. So how do we balance it? Exactly, put a 2 here, and that's it. Okay, so that's basically how that is done. Okay, the next one is iron plus water to give you Fe3O4 and hydrogen. So the formula for iron is, what's the formula for iron? Fe, and we all know the formula for water is H2O. And then on this side we have Fe3O4, and the formula for hydrogen is H2. So we need to balance this. So how would you go about balancing this equation?
Three, one.
3,
No.
4. 3, 4 what? What's on the other side?
3, 4, 2.
3, 4, you sure about 2?
4, 1, 2.
No, not 1, 2. Well, 1 is correct.
3, 4, 1, 4.
Oh,
Exactly. 4. The balance. All right. Any questions? Any questions? Okay, let me clear this. Go down. Zinc sulfide. Yeah, zinc sulfide plus oxygen to give zinc oxide and sulfur dioxide. So okay. So what's the formula for zinc sulfide? Again, that table will have to be consulted. What's the formula for the zinc ion?
units.
Okay, yeah, okay, the answer is ZNS. But just to briefly explain, zinc will be +2, sulfide will be -2, so when you come together, it forms ZNS, plus oxygen. What's the formula for oxygen? O2, very good. And then what's the formula for zinc oxide?
It's unit.
ZNO. And what's the formula for sulfur dioxide? Sulfur dioxide.
SL,
SO what?
SO2.
SO2, exactly. Remember dioxide or di means 2, right? So this is not balanced. So how do we go about balancing this?
That a 5 behind the first C.
No, S.
That's fine.
Sorry. Yeah, I don't have the best of handwriting. Let me make that look more like an S. Okay.
Would it be 2, 3, 2, 2?
Mm-hmm. That would be indeed correct. All right, let me check and see what's below here. Declare this here. Scroll down. Oh, all right. So what I'm going to do is I'm going to leave all of this for you to do. That's pretty much all I have for you today. What I can do is hang out here. If you need help in doing the others. Let me before I forget, let me set up a Dropbox for this one right here. Assignment 6. Okay, so okay, so I'm going to let this be due on Thursday, the 19th. Yeah, you should be able to do that, do all of that with it. Easy stuff. Okay, so that's like
Right. Yeah.
okay. Okay, so let me just save this. And while I'm at it, I'm going to publish the videos for the next chapter, which is chapter 7, which deals with the different types of reactions. So make sure that you watch those. Not a very large or long chapter, as you can see, only 3 links provided. So make sure you watch those videos in preparation for your next time. All right, so that's pretty much it for today. Yes, sir. Yes, sir. Oh, 1 minute. Let me bring this up here. Number 12.
6.
Section B, okay.
Yeah.
All right, so number 12, section B.
So it's the
rate.
this, what's it called, hydroxide. There's no, I don't see hydroxide, product size.
You don't need to. What you're looking at is, in order to balance an equation, you're looking at the total number of atoms of each element on the other side. So you can have a situation where you have hydroxide on the left, but you don't have it on the right.
Okay.
But you're looking specific, like in this case here, what I would do is, because you have 2 oxygen here, and you have 1 here, I'll put a 2 here, right? And because you have 2 hydrogens here, you have 3 hydrogens here, you have 4 here, I would say, put a 2 there.
Okay.
And I think that is right, that will be the balance equation.
Thank you.
Yeah. And that includes you guys in Zoom. If you have any questions, feel free to type it in or simply ask. That's why they gave me the big box.
Wait.
This is the coefficient.
Okay, somebody's
This is 670.
asking something. Can you publish? Oh, I'm so sorry. I didn't realize I didn't publish the assignment. Please forgive me, forgive me, forgive me. Let me do that right now. Okay, so 6.
He's going with hydroxide right there.
Oh, and by the way, I'm quite sure you saw the grades I've put in for your assignment number, was it 5?
Yeah.
Okay, so, I'm going to scan your assignments and send it to you. So expect it later on this evening. All right, and I'm also in the middle of grading assignment number, oh, wait a minute, no, wait a minute. Assignment 4 is the one that I've completed grading. I'll scan that and send that to you. Assignment 5 is this right here, I'm in the middle of grading, so. I don't know when I'll be finished with this, hopefully by tomorrow.
I have a question.
Yes, sir.
Number 13.
Number 13, hold on 1 minute. Number 13, this one right here?
Yeah.
Okay, good. What about it?
You know, walk us through.
Okay, so, all right, let's start off with the aluminum.
Do you wanna know what we have down?
Do you want to?
Oh, let me hear what you have.
You got it. 2, 1, 3, 1.
2, 1, 3, 1.
Yeah.
No.
No, it's 6.
All right, let me erase these numbers here. You're partially right, but not all the way. You're right about the 2. I will put a 2 here, to balance with the 2 aluminum here, right?
Yeah.
But now you're gonna have 2 times 3, 6 bromine.
Oh, which there's 8 O's and.
Because remember, this 2 multiplies everything here.
Okay.
So I will put a 6 here.
Whoa.
You get 6 bromines here.
Oh, cause the 2 times 3 beneath the R.
Exactly, right?
So we got 6.
Exactly, because you have 6 bromines here. So that means I'll put a coefficient of 6 in front of the KBR, right? Then, because you multiply this by 6, you're gonna end up with 6 potassium here. You have only 2 here. So what would you do?
4.
No. Not 4. 3.
What? That number added.
So now we have 6 potassiums on both sides, right?
22.
And let's see. As far as the sulfur is concerned, 3 times, that's 3 here,
6.
and this is 3 here. And then oxygens, you have 3 times 4, 12.
Yeah.
You have 12, so everything is balanced up.
I'm just gonna write good ones.
No problem, no problem.
So.
Yeah.
No, bro.
14.
Yeah.
Oh, I already got
This is 4. So that's 6 O. Oh, wait, this might have to be a 2.
So we got, we got.
Well, this is 4, so 4 plus 2 is 6.
Alright, we got one more.
All right, shoot. Which one? 14?
Yeah,
I think it's supposed to be a 2, right?
Let's scroll down.
Are you ready for it?
Okay, 14.
Alright, you got
6.
All right, let me hear what you have.
1, 1, 1, 4. No, 2. 2. 1, 1 was this right there.
1, 1,
Is
1, 2.
Yeah.
I think that is correct.
Oh,
No, not correct.
Oh.
This is not right.
Wait. Was it not right?
Because
Because you have 3 oxygens here, you have 1 here. So let me,
How do we have 3 oxygen?
And then we
Because
go
it's
Two.
O2 and O.
1.
Oh, and then the last one, so you gotta.
Yeah, exactly. So let me go through the steps of this one. Alright, so you have 1 carbon, that's fine for the time being. You have 4 hydrogens here, you have 2 here, so I'll put a 2 here, right? Now we end up with 2 plus 2 oxygen, that's 4. So I will put a 2 here, and that takes care of that. So it's 1 to 1.
Alright, let's try 15. Yeah, this one.
It's 6.
Alright, we got this.
And then
So this is coordination. This one's, yeah, 14. It's like games too. So that we did. Yep. So let's really fast.
Nothing right here.
This weekend is
Okay.
so one seated. Yes, so
That's what I was.
yeah. Wow. So does that mean 16 is 2, 1, 2?
2, 1, that's correct. That's correct.
I'm slowly understanding.
What's that?
I'm slowly understanding.
Yes, you just have to practice. That's the reason why you do all these problems. The more you do these, the better you become at it.
Are you ready for our 50?
Which one? 50? Okay.
Okay, so right now, we're sitting at 1, 3, 2, 1.
1, 3,
12 O's.
2.
12. Yeah, because 6 plus 2.
Okay, it's not correct.
So 6.
We have.
No, it's not correct. Okay, let me go through this one.
So that's 12. So that's 16 minus 2.
So in this case,
Here.
you have 3 sodiums, right?
Yeah.
So I'll put a 3 here. You see that? Because I have 3 sodiums here, I will put a 3 right here, right? You have 1 phosphorus here, you have 2 here. So what I would do is put a 2, no, this one you have to go back and forth. Let me just warn you, right?
Okay.
Because you have 2 phosphorus here, you have 1 here, so I'll put a 2 here, which means that you now end up with 6 sodiums here, which means,
This has to be a
yeah, exactly. All right, so, let's see now, the oxygens, 2 times 4, 8, 2 times 4, 8, so the oxygens are okay. You have 1 calcium here.
Yeah.
You have 3 here, so I would put a 3 here, right? And then 3 chlorines here, 3 times 2, 6 chlorines. 6 chlorines, so now the equation is balanced. So okay? So yeah, this is one of those, you have to go back and forth,
In there.
you know?
Right.
And I would recommend that when you're doing these, do it in pencil first and then give your last answer in pencil.
Something more O's, so 3 plus 3 is 6. We have this zero balance, or this is also 8.
Think of that.
Times 3. So usually it's a combustion reaction. A combustion reaction.
Oh, either 2 Ks.
Yeah, well, like 13.
2, 1. Actually, there's 2 25, 2 days.
So it's I was confident in this one.
Number 16, 2,
What, 20?
1,
What?
2.
Number, oh yeah, that's easy.
Alright, on 24.
Yeah, we got 2 on.
You got 20 on? Yeah, that's right.
Alright, so punch, so right now,
I'm on 32.
They said 2, 1, 2, right?
Yeah, 2, 1,
Yeah,
2.
2, 1, 2, that's correct, yeah.
Yeah. So for number 20.
Number 20.
There's multiple numbers.
Because this 2 multiplies everything
You
in
get
here.
this done in like 5 minutes.
It's all good.
No, but the
Yeah,
was
32 is all good.
Everything else is.
Yes. Yeah, 1, 1, 2, 1.
We chose over this one. It did so good, and now you're cracking.
That's really good, because this way, no, this have to be a soup. We think so, so this, and we have four agents on one side. What happened with this body? Four agents. This was very two was big range.
That it's yes. Yes.
I was going back, there are two lost passions for us. The first one, yeah, is the H2. So then you use eight, so that's four. So that's eight plus four is 12. 12, so 6. 0.644. Alright. You check number. That's gonna be that.
Number 17.
We got another something. 2632.
0.644.
2, 6, 3.
No,
2. Yeah, that's good.
That's listen, since this three
three, two, two, or 2, 3, 2, 3. You know, but I messed up. So I gotta wait. Alright, it's gonna have to be 2 right here.
6 here.
Six. So this is going to be. They're all 6. Well, it's already 5. So 5. So that will be 1, 2. No, 1, 3, 8. So it's 3.
That's what we said.
Okay. 1, 3, 2.
I
It's not 6. So it's not it's gonna have to be
18, 1 through 2.
Oh, come on, man, that's too easy.
Took me like a minute.
Yeah, that took me like 15 minutes.
I mean, you're going. You're
No, I had
good.
to get my calculator for that.
That's correct.
We don't got.
Yeah, you have 2 nitrogens on both sides.
It's a shit.
And 6 fluorines. You can see 6 fluorines. Yeah.
This is just, you don't register. So, basically, what you need to do as well. Look at the fish, so that's 3.
Everybody sign the attendance sheet.
That happens with 7 without it, or so we need, so we're gonna have to shut it all up. Trying to include it all, or even. April 30 now, that will have it, LI at 2. So there's 3 times 2, 3 times we got for 32. That's neat, but usually already had it for 32.
1, 2, 1, 2.
Which one?
6.
19?
Yeah, I knew I had to do that.
Let's see here. It said 1, 2, 1, 2.
Yeah.
12.
Okay.
See, I just didn't want to do that.
Okay. Yeah, that's correct.
Breathe, and this would have to be a word. So 6 plus 4 is 7. It's a scale of 3, so this is gonna be that.
Which one?
22.
22.
Yeah.
Okay,
You want to do.
okay, so in the case of 22. All right, so the first thing I noticed is you have 3 hydrogens here, you have 2 here, You can balance the hydrogen by multiplying, this by 2, this by 3. And then, you have 2 phosphoruses here, so that's balanced. You have 8 plus 2, 10 oxygen. 8 plus 3.
Millie is crazy. I've been playing this since 600.
Oh, I'll put a 3 here.
I know, bro. My sister put me on.
You see here, so that's 3 ions on both sides.
I can type it.
So that's 11 oxygen on both sides, because you have 8 plus, no, 2 and 2. 8 plus 14.
It's gonna have to be 16.
8 plus, oh, so this needs to be changed to a 6.
Bang.
You don't go for it already, right? Those are two baby numbers. Two baby numbers can't think of
We
it.
don't just have to write it down.
I think that's it, so 6 nitrogen, 6 plus 6, 12, 2 phosphorus, 2 phosphorus.
On.
8 plus 14 oxygen, 6 plus 2 on 1. Yeah, so that's it.
I got 1, 8, 10, 6.
Yes, sir.
Number 20.
Number 20.
We got 2 on the one.
Let me scroll up.
Yeah.
Okay, number 20, man, you're
So this is.
doing all the easy ones.
This is not easy. We're building.
Oh, what's easy?
We're building an old we're flashing.
Oh, because you have 2 nitrogens here, 1 here, so I'll put it 2 here. And 2 times 3 is 6 plus 2, 8 hydrogen, 2, 4, 8 hydrogen. 1 sulfur, 1 sulfur, 4 oxygen, 4 oxygen, so.
Chemistry is probably the easiest thing.
Two LIVs are.
It's 21. You're like the old man. It's all right.
We already got 2, so it's
1, 2,
Yeah.
So the 1, 2,
1, 2, 2, 1.
call me a freaking genius, bro.
Absolutely not.
We're getting there, bro. And then is, chemistry, what?
It's 22.
22?
Yes,
Six.
please.
Yeah, just do that one. It was 2,
3, 6.
3, 6, yeah.
Well, 8
Yes.
Yes, sir.
When we're running out like a polyatomic ion, like hydroxide, can we put it in the parentheses?
You have to.
Okay.
If there's more than one represented in the formula, yes, you have to put it within parentheses.
Okay.
Yeah.
Thank you. So it has to be. So yeah, okay, really nice, right, page 10, where you take one new, go, take the other thing, and you leave them together as one. Yes, and that's on the quality for the 1. 2, alright. But sometimes, like, what he's asking, is what is 2 that has supposed to 2. Say 2. So that's non-polyatomic, you take 3 elements, and you switch them together.
And then you got.
Oh my god. Oh wait, no, this is not a virtual difficulty. We're just gonna have to do it. Did you speak yet? Or you working on it?
Absolutely.
Pass it in. I'm doing 7. Did you get, so you.
Alright, this one.
You put a 6 on the screen.
Which one?
Okay, that's what I thought.
22.
So, got a 6.
Oh, 22? Alright, hold on, let's clear it first. Okay, so in case of 22,
Is that?
the first thing I noticed is,
You got
No, we
6,
have so far, the very first box, we have 2.
and then number.
you mean here?
Yeah.
Yeah.
Okay, yeah, because what I would do, because you have 3 here and 2 here, I'll multiply this by 2, and multiply that by 3 to get the hydrogen balance.
I wish it was one.
Right?
One.
Now, this 2, we multiply the phosphorus here,
So,
so that will be 2 phosphorus, which is already 2 on the side, so that's okay for now. And then we have 8 oxygens plus 2, 10. Here we have 3 plus 8, So that's 11. So the oxygens are out of balance.
8.
Now, what I would do is
Got it.
I will put a 3 here.
But then that would put your oxygens on this side, like.
Oh, ammonia? That's the
Well,
one I
if
know.
we put a 3 here, that would be 6 oxygens plus 8 plus 8, that's 14.
Yes, Ed.
Here we have 3
You said I'm
plus 8,
ammonia, yeah.
that's 11. So what I'll do is multiply this by
Not ammonia, it's the only one I know. Exactly.
You said 8, 2. How do you know that?
Yeah, 2 by 40 is.
so
The only-
let me check both of this one. So you have
Apart from, yeah.
12 hydrogens on this side, which balances the 12 on this side. You have 8 plus 6, 14, 6 plus 8, 14. Let me see what else. 3 irons, and that's it. So yes, that's the balance equation right there.
You don't know, it's 23 weeks.
23, okay, so in the case of 23, they gave you 3 carbons here. You have 1 here, so I'll put a 3 here, right? And then now for the hydrogens, it's a total of 8. I have 2 here, so I'll put a 4 here.
Almost 500.
And then now for the oxygens, I have 3 on this side, I have 6 plus 4, 10. So, let me see. Okay, this is one where I have to use a fraction. I will put 9 over 2 here.
It's NH3.
Because 9 over 2 times 2 gives you 9 plus 1, 10, which balances with the 10 here.
Yeah, it's NH3.
But of course, I would multiply right through by 2.
Uppercase.
Right? So when I multiply right through by 2, this becomes 2, this becomes 9, this becomes 6, and this becomes 8. Let me just check to make sure everything is balanced. 6 carbons, 2 times 8, 16 oxygen. I'm sorry, 16 hydrogens. 8 times 2, 16 hydrogens. And then 9 times 2, 18 plus 3. Oh, wait a minute. 2 plus 18 is 20. 6 to 10, 12, 6 to 12, plus 8, 20. So yes, that's it.
I got.
So it's 2968. 2968.
No, it's not. We're gonna have to change the.
Why?
That's
Why?
because.
Or 5 minutes or 6.
Yeah, Let me rewrite it, because I already missed that. I'm writing it.
Maybe with the letters in the pen and not the coefficients in that something. Because I'm not getting a great number tonight.
Wait, so what'd you get?
4, 5, 4, and 6.
4.
Okay, sure.
Yeah, that's right.
Phosphorus is what?
Phosphorus?
Yeah, P4.
Plus.
Can you walk us through
2203,
24. Okay, let me clear it here.
and then. E4.
Okay, so in the case of 24,
10, that's.
here's 1 nickel on this side, so you have 2 on this side. So I will put a 2 here.
Alright.
Then now for the oxygens,
Oh, man.
okay, so it's
We gotta
2
start.
times 3, 6 oxygens on this side.
6 possible.
I got 3 on this side plus 1,
Oh.
so that's 4. What I will do is put a 2 here.
Oh,
No, just go on
No, a 3. I put it.
this. Since it's 03, we're gonna have to do.
I'll put a 3 here.
30, right?
So I get a total of
Yeah.
6 oxygens on the right.
Yeah, I think
3, 10.
And let's see, the hydrogens
10,
are balanced because
I got
you have 6 hydrogens on the left
3.
and you have
Yeah.
3 times 2, 6 hydrogens on the right. So that's it.
Good job. Thanks.
Mm-hmm.
Well, yeah, he's great.
Cupric?
What is that?
Yeah, I've never heard of that.
Yes, sir.
What is a cupric?
Cupric is the same thing as copper two,
Okay,
right?
oh, I
Yeah,
see,
it's in
oh, I
the
see it
table,
right
right.
here,
Copper two is the stock system, cupric is the classical system.
got it. So. It's so.
So it's just.
Yeah. Oh, wait. Oh,
Did you forgive me?
yes, yeah. Let's go to. And then it's. Yeah, right, yeah.
I go to Commodore CU.
No, Coles. Oh, yeah.
Commodore CU. Commodore CU. The CU for Commodore.
Yeah, it's that's. The CU.
I didn't even realize that.
CU tables. Oh. Plus. That's so true.
Yes.
Okay.
All right, 25.
25.
Is it one,
We're gonna have to
two,
put
one?
two in front of the C.
Just see here,
I believe it.
Okay, 25 is
Four. This is gonna. Plus two, so. I got 4, 5.
you said 1121? Yeah, that's correct. Yeah, that's correct.
4524.
Yeah, that's what I got. Oh my gosh. Where's my? Okay. So it's N A, and then parentheses. CO3. And then 2. I think it's NA parentheses CO3. Yeah. This carbonate is CO3.
Oh, 505.
Yes. And then you have say those.
Yeah, 5 carbonate.
It's 26, 2, 1, 2, 1.
So I think it's 2 carbonate.
Might be, I think so.
This is 5.
Yep,
5.
yep.
But it's them. Hydrogen sulfur.
Yeah,
See, but it says 5, right?
what's like, I feel like bicarbonate something else.
I do. This is kind of, yeah, I'm looking right now.
What's news is that the first one?
So, yeah, well, if that, we can apply for now.
2, 1, what? Yeah.
Yes, sir.
So it says sodium bicarbonate,
Okay,
right? So we would write, when we write NaCO3, like parentheses from the CO3 and then.
no, sodium bicarbonate. Bicarbonate, the formula for the bicarbonate ion is HCO3 minus.
Okay,
And the sodium is Na plus.
thank you.
So when you put it together, it becomes NaHCO3. And the other name for it is hydrogen carbonate. If you look at the tables, you'll see they give hydrogen carbonate or bicarbonate, the same thing.
Okay. Oh, I see. Okay.
Also,
Yeah, it's like right here. So it's in. It said this is hydrogen carbonate.
one thing is behind, 2 behind this. Yeah, I saw that. Like, 3, 4.
Yeah, sure.
I was gonna say, oh, because I think.
Oh, it was underneath it. And then the hydrogen still.
SO, record, right?
So big SO4, yeah.
So it's just HSO4, right?
It's H2.
So this is.
Because
So got the hydrogen, you tell me.
because sulfate has a 2 minus charge. So H2 SO4. And then NA charge now.
It's 28,164.
Okay, that one I have to work through, let me see.
Holy crap. This is gonna.
So you have 4 carbon on the side,
Oh, yeah, so that's so two period.
4 2 is 8 plus
And then
4 12.
that would be. Yeah,
So this would be 6.
so we have to.
Oxygen. 6 times 2, 12 oxygen, so balance with the 8 plus 4, so 4 carbon. So this is the answer right here, 1644, that's what you got?
Yes.
Okay.
That's 4 years. And so.
One GA.
That would work.
There's. And that makes you have 10 days.
We might be, we're gonna need.
So if you want.
We're gonna need 6.
It's 29,
Part of the third
1,
one.
Let's see. One,
Yeah, we're
one,
gonna
one.
need 6 in front of the
No,
first.
1, 3.
No,
Or 4.
I'm just working this out.
It might be 4. And then we put a 2 in front of this.
Yeah, 1, 3. I don't know. 3, 1, yeah.
Then we would have to put a, yeah.
Yeah.
And then.
So you gotta do 3 and 2.
Yeah, let me.
You gotta. Right, which one has 60 of them, so 4. So you. Yeah. That's a part of the. Yeah.
Well,
They got 10 sheets, so you got 2.
Make some use.
Work. Sense you. And that and 6.
6 plus 8.
So that's
14, and then this would be
48.
12 plus 8.
Is 32, 3, 2, 3.
32. Okay, what did you say?
2, 3, 2, 3.
No, 12 plus 8, so.
3, 0. I think that's
Or.
the one started was
Where do you?
4224.
Okay, so we're doing.
Okay, yeah, that
The one
makes sense, 'cause I
The
was
one
getting,
started
I was
with
looking at the
the
first
one,
3,
two.
and I was just figuring out.
Oh, you mean this one?
Yeah.
Oh, my bad, my bad.
Okay.
Okay, so you're saying this is one?
2, 3, 2, 3.
Yeah, that's right. Got
Hello?
2, 3.
Dealers.
Yep, that's correct.
Is 31,
Yeah,
1,
no,
3, 2?
no, I don't got.
Let's see. 2 arsenics here, 1 here, so I'll put it from here. 6 hydrogens here,
These up on me, bro.
2 here, so I'll put it from here. And that's still a oxygen, so you have 5 plus 3, 8. So you said what, 1, 3, 2?
Yes.
Yeah, that's it. So, bro. 1, 3, 2 is first.
So job.
Okay, wait, last page, lock it in. I'm smart. You ain't logging in. So job. It's notification for the end of it's any to. I ghosted her for like 4 months and then had this joke and then texted back and I was like, yo,
It wasn't a
yo. No, what's good? She's like, really? Are you really? And I was like, yes, mom. And now whenever I'm in the hall, isn't she from my? Oh, sorry, she didn't want me first.
Yes, fine.
Then she wanted to start, probably. But this is it. I'm even excited about that. She wanted to speak to I was because I already had it. No, it's weird. Wait. She wanted to, bro. She's a great cat. I'm telling you, very long wanted. I did that. She wanted it, bro.
Yeah, wait, it's fell. You might have pulled her, yeah,
I did a.
Absolutely not. Absolutely not.
So any two CO3, what's silver?
Silver's like HE, right?
Yeah, HE. Nitrate. So good.
Would you say it again? Na2CE03.
So 8, right? It's Na2CO3 HE NA, those three. AG. CO3. It's already. Oh, wait, AG is AG2.
Oh.
Is there a AG2,
$33?
so. We gotta put a 2 in front of it, so it's one. The one,
Okay.
2, 1.
We got 2, 7, 6.
I like how some of them are like.
Said
you
2,
know,
7.
And they're like, okay, 30,
And then
40, it's like, nice.
110, 25.
Exactly, like. We're close, we got to 20.
That's it. 276.
I meant like for coefficients. Yeah, we gotta.
Yes, sir.
We gotta, yes, we got to 30.
So what?
Yeah. There's calcium and diatomic.
One. Was this number 33?
Calcium?
Yeah.
I don't think so.
I don't think I should know, so.
He was- Now he leaves, right? It's like, all right, I'm gonna let these two do it.
It's 212. 212 is what I got.
Yeah, we want to watch it.
It's 33, 1, 5, 3, 4.
Good.
See.
Hold on. I'm sorry.
So can I? Look, that's a bit.
No, it's not.
We go through
What'd
the
you say?
steps here.
First
I'll put the
2, 1, 2.
first. And then.
The CA and O supposed to have a -2 positive charge, so it's well. So it's CaO.
That's 6 plus 4, 10.
All right.
As in,
Yeah, that is correct, actually.
It's the end.
45.
Replacing this.
Yeah,
Yeah.
what did you just?
but I think it should
Wait, that's not like a subset.
Yeah.
Like, see.
I think it should CN. Yes, it's just like.
Very oxide.
Or
Top of the left, this one is 2 O's.
there.
Yeah, this wouldn't work
There.
because,
There.
um, this would give
Right
you,
here. It's iron.
18 plus 8 oxygen, which would be 26, that is 7 grams to 4 grams, so that would balance. So it's
At E2.
1, 5, 3, 4. That would be the answer.
6.
And then what charge did it?
Positive 2.
Okay, so it's
Yeah,
CN,
that's it.
CNO plus FE. We're gonna put a three in front of it. Okay, so it's 3, 1, 3, 2.
Yeah.
And then magnesium oxide is.
Wait, what'd you say? What'd you say? Keep listening.
3, 1, 3, 2.
In 3, 1, 2. Ow.
Because there's, we need 3 occupants, so I put a 3 in front of DNO, so, right? And then since there's 3 things on that side, I put a 3 in front of the DS on the other side. Since there's 2 irons, I put a 2 in front of the iron on the right.
It was iron 3.
Yeah, but it doesn't say iron 3 on the other side.
So it
I think it's just FE.
I guess that makes sense, yeah. So you said
Good.
3.
3, 1.
That's that or.
And then
So I got, yeah, one of the
MG. Geez, so it's,
MVBRs.
yeah.
Yeah.
Plus CL2.
Yeah, you know, one was just.
I don't want to go to crack. Oh. DCL2 plus BR2. Yes, it does. It's already balanced.
Yeah.
And then it's certain lines.
So there's 2.
I know it's not safe. H6 NA plus H2O. And what charge is NA have? Okay, so it's NA OH we had was.
Yeah.
Yeah, so we're gonna need to multiply
Yeah.
by
The three numbers.
mass production.
That's what I got.
The little box. Something like that.
You guys say
Next one.
saying though, like.
This guy.
I'm just saying. He's even feeling for the question.
Yeah, yeah.
He's speaking, looking at. He's using his eyes, just not his brain.
It's and arrow, nitrite.
Please, can
You don't know if it's Fridays or.
Isn't nitrate like
you?
yeah.
Whenever I have eight, usually bigger than that.
Why bigger?
It's C. C6.
Yeah. I remember that. Wait, so.
Okay, so.
It's probably.
First word two.
I think we're gonna have to put in four.
Okay.
So,
We're gonna put it- Yeah,
1 to 6.
I believe so. This one would work.
But two words? So six elements. Six elements.
Oh, yeah, two would work.
Yeah.
Six
Yeah.
times two.
Two, two, one.
Yeah, 221 works.
Eight, that one was 16.
Oh, that's basically.
Oh,
what
is
it's
it?
like.
I just want that.
Yeah, it's it.
Eight, nine,
Yeah.
16, and then
Calcium.
seven up.
Which is 14.
And then VAO.
Yes.
Yeah, that. Which would be.
Hydrochloric. Oh, I messed up with that.
That's really great. So I was right first.
Is HCl.
It's just.
Okay.
Little.
Oh, yeah, you're right.
Hydro, so.
You're right.
Oh, not really.
HCl,
So,
calcium chloride.
That's why it's kind of-
CaCl.
oh, wait a minute.
That's
Okay.
just that much long.
But 7 times 2 gives 14 ounces.
86.
Here, 6
You're
times 2,
correct.
12.
You're not seeing
Plus
this.
eight.
Not seeing what you gotta read your shit. I'll give you a hug.
Okay.
That's what I'm saying.
No, you're not seeing what I see, bro. She's a,
Mistake.
she's a, let's say,
Mistake, we both
rookie
did.
season,
We
bro.
were just doing this, is that we forgot to multiply that 2 first.
She's gonna be rookie
Plus 6
season.
times 2, 12, plus 8, 20. Yes, sir.
She's dating.
No, I just said that, I've graded assignment number 4, so you should see it reflected in your, oh, you go to,
Crazy ass.
when you go to,
It's 1, 2, 1, 1.
when you go to canvas. Alright. And, you go to.
Magnesium.
grades,
Is it?
And,
1, 2, 1, 1.
that's it.
Why not? Yeah,
Yeah, 19, yeah.
yeah, I think it is, cause calcium, 2.
What's
Yeah,
that?
yeah.
Yeah, it is.
Monatomic cations. MG is just regular, right? Like, that's not the deal.
It's okay.
Again, you.
So it's fair, you gotta tell them things that you're saying.
I don't think so.
Yeah, nice one.
Magnesium, oxide.
I'll leave it so.
It's okay.
Only find something, right?
So.
No, the first time actually messed up, so everything good. Yeah.
Yeah, too.
So it's.
We're gonna have to multiply.
Did you send it to me by email?
E
No.
plus O
Should
two
we spend some time on, I'd rather somebody PDF correctly,
FEO.
at least save as PDF, instead of submit it as.
Same thing. 257.
Little.
We're racing the clock. We got 2 minutes. Plus N2O nitrous fat.
Nitrous at us is it. E is I, us is Nick, so it's nice. Right,
Nitric.
nitric. So ig is, no, ig is D, I think, us is like, us is G.
Right.
I.
If it's PNG, yeah.
Yeah.
You have to resubmit
Yeah,
it,
sure.
well, you can't resubmit, you have to send it together, as email, but make sure it's PDF,
Yeah.
I'll do it right,
alright.
thank you.
Alright, folks, 2 minutes left in this joint. I've got to eat.
Dude, we almost finished. We got 3 more questions.
Get 2 minutes left.
Thank you. Have a good day.
So take care.
Think about it. Yeah, it does.
I'm just trying to finish it, you know,
Back into the
I'm just trying to finish it, it's just.
nitrous acid. What? Okay, great. When you're doing acids, nitrous would be nitrite, right?
Well, yeah, the nitrite ion would form the nitrous.
Okay, yeah.
And the nitric acid
Would
would
be
form the nitrate.
nitrate, yeah,
Exactly.
thank you.
Alright. I'm fine, guys.
Right.
Just gonna finish this last two questions, when I get home.
I'm just doing things now.
You have your day.
All right, take care.
Think I'm. Alright, we got this, we got this, like, you don't